Greetings, math fans. All right, so this is day 6, and these are vector examples using law of sines and cosines. So we've already talked about how to work with vectors, and now we're going to have some applications. And I would say the hardest part of this unit is getting the right picture, because once you have the right picture and you have your triangle, it's pretty easy to pull everything off. So it's really just drawing a picture, and you're required to draw a picture for every one of these problems. Okay, so let's get started here. But again, just remember, it's always using law of sines and cosines. Okay, yeah, or maybe something else. All right, so the first problem: Shannon is pushing a 2,000-pound car up a hill with a 4-degree slope. How much force is required to move the car? So what we're going to do is we're going to just draw a nice little picture here, and this is a right angle, and this is definitely not to scale, but this is 4 degrees, and I'm going to draw a box right here. That's our car. I'm not very good at drawing cars, but that its force is going down like this, and this is 2,000 pounds. All right, and let me draw this in red. This is what we're looking for. We're looking for this force F. Now, I want you guys to understand that you want to think logically and see if your answer makes sense after you get your answer. Right? It's a 2,000-pound car. You're pushing up a 4-degree slope. If you ever try to push a car in a parking lot, it has like a 0 slope. All you have to do is kind of get it moving a little bit. And if it's got, you're pushing up a driveway, if it's a 1-degree slope, it's kind of hard to push that car up there because the car is, whatever, 3,000-4,000 pounds. It's tough to push it. And as the slope gets higher and higher and higher, it's more and more difficult to push the car. So just kind of keep that in mind when you're doing your, coming up with your final answer. So as I told you guys, with this red force I just drew here, you can actually make that force move around. If you guys remember when I talked about it back in the day, about forces can totally move around as long as it has the same direction and the same magnitude. So I'm going to take that force I just drew here, and I'm going to redraw it right here. Okay? I'm going to call it F. That's truly what we're trying to find, that force, how much Shannon is pushing against that car. And then what I'm going to do is I'm going to draw a triangle like this. So this is actually another right angle there. Now, I want you guys to understand that this angle, these triangles are, first of all, they're similar. So the actual right triangle I drew for pushing up the car or pushing the car up the hill, and this triangle I just drew, these are similar triangles. And how do you know that? Well, first of all, see this force, the two forces that I drew. If I mark this one angle right here, not the 4-degree angle, but the one in blue right there. Do you guys agree that angle is, because again, this is also, let me sketch this in here. This guy here is parallel to that force, right? So that angle and this angle are equal. And how do you know that? Because they're ultra interior angles. Okay, and so if those are equal, and that's a right angle, that means that 4-degree angle, I'll put that in green here, this 4-degree angle has to be the other angle. So that 4-degree angle is right here. And again, you kind of get used to it after a while that that 4-degree angle is the angle that's on top there. All right, so now what you have is you have a nice right triangle. Now before I even go any further with this is a really common mistake that people do, is they draw it down like this, and then they draw a right triangle like this, okay, and where this is your force, right? But you can even see it's impossible. It can't be the force because it's certainly not parallel to that other force. So don't do that, because then you're going to get, you're going to put the right triangle or the right angle here, and the right angle should be right there. Okay, so let me erase this here. All right, so what I want you guys to do is I want you always to redraw the picture, because it gets all messy when you have your sketch. And here's your right triangle, and again that 4-degree angle is right here, and this is 2,000 pounds of the force of the car, the weight of the car, and you're looking for F. And basically, do you use law of sines or cosines? Well, actually, you don't have to use either one. You could use law of sines; it works fine for it. Okay, but actually, what I'm going to use is just right triangle trig. So if I say right triangle trig, that's pretty handy, because you're just going to say sine of 4 degrees equals opposite, so it's F over 2,000. Okay, pretty easy. Cross multiply, and multiply it all out, and you get F is equal to 139.5 pounds. Okay, so do not forget your units. That's actually cost you a point, and make sure you read what I'm asking for here. I ask you guys to round to the nearest tenth, and I think that's usually for most of the problems. If I ask you to figure out an angle, it's probably to the nearest minute, or it could be a tenth of a degree, but just kind of be aware of what I'm asking you guys to round to, okay? I certainly would take off a point for every problem, but I would probably take a point off for a quiz, 1 point, or 1 point for the test. So you don't want to forget that. All right, so let's go on to the next problem here. And so it's interesting. I made this worksheet a while ago, and so these people on here were the first people that I made the worksheet for. So it's kind of, they may be a little bit different for our class, but it's a general idea. Same general idea. Okay. So number 2, Ryan and Ashiel are trying to pull Mr. Curvis into the pool. Ryan pulls on one of his arms with a 200-pound force, while Ashiel pulls on the other arm with a 250-pound force. The angle between Ryan and Ashiel is 40 degrees. How much force does Mr. Curvis need to exert so he doesn't go into the pool? Okay, so what we're going to do is we're going to, again, draw a picture. First of all, one is a 200-pound force and one is a 250-pound force, and the angle between them is 40 degrees. So let's kind of sketch it here. And again, not to scale, no big deal. So this is 40 degrees between them. One is a 200-pound force and one is a 250-pound force. And what we're going to do is for this problem, for a lot of these problems where there are two forces acting on something, we're going to use the parallelogram method. We already talked about that. So here's your parallelogram method, like this, and there's your resultant force. Okay? And so, again, it's 40 degrees between these guys, and then you're given all this information, the 200 and the 250. So what we're going to do is that 250, I can write this over here, because remember, opposite sides of parallelogram are congruent. And if that's 40 degrees, what you can do is you could say this angle right here, if you remember that we say consecutive angles of a parallelogram are supplementary. So these are, since they're supplementary, then you're going to say 180 minus 40 gives me 140 degrees. All right? So when you think about it, I have enough information here, math fans. Look at this. This is 200, this is 250, and this is 140 degrees. That's all I need. And I need to figure out the resultant force, X. What do you use? Well, the only thing you can use, because remember, back in the day when I asked you to draw what information is given, you're going to say side angle side. So if it's side angle side, the only thing you can possibly use is law of cosines, because you don't have an opposite side and angle to use law of sines. So pretty easy. So it's x squared equals 200 squared plus 250 squared minus 2 times 200 times 250 times cosine. Again, it's law of cosines. Don't forget to use cosine. Cosine 140 degrees. Okay, and we multiply all that out. Take the square root of it. Don't forget to do that. You get 423.2 pounds. So once again, don't forget your units. And think logically, this kind of makes sense. The most this could possibly be would be 450 pounds if they were actually, where there was no angle between them, like a tug of war. So 423 pounds is a little bit less than 450, so that's a reasonable answer. Okay, not bad. Let's move on to the next one. All right, number 3. A force of 100 pounds makes an angle of 60 degrees with the second force. The resultant of the two forces makes an angle of 35 degrees with the first force. Find the magnitudes of the second force and of the resultant. So, again, it doesn't really matter how you draw that first force, because I'm just going to kind of draw it down like this. And this is 100 pounds. And so I'm going to label this the first force. First. And then this is the second force. And that's 60 degrees. Okay, the resultant, so we're going to do another parallelogram method. And there's that resultant. Makes a 35 degree angle with the first force. So this is 35 degrees here. Okay, and then you want to find, we'll call this, so this is the resultant, so we'll call this X and Y. All right, so basically I'm going to kind of transfer some things over here. So that's, because we're dealing with one triangle. So let's make this 100 because opposite sides of a parallelogram are congruent. And if that's 60 degrees, that means this has got to be 180 minus 60, or 120 degrees, right? And that's 35 degrees. So that means this has got to be 25 degrees here. And how do you figure out this angle right here? Well, a couple ways you can do it. One is, since these two lines right here are parallel, that 35 and that 35, because they're alternate interior angles. Or you can just say, well, I have a triangle here, so 180 minus 120 minus 25 gives me 35. Either way you do that, that gives you that angle. So the beauty of this, if I'd actually sketch this triangle again, we're going to call it again this X and this is Y. This is 25 degrees, 120 degrees, and 35 degrees. And then this is 100. And what can we use for this one? Use law of sines, because we have an opposite angle and side. Okay, so use law of sines. All right, cool. So let's do that. 100 over sine of 25 degrees equals y. Let's do y first, I guess. Okay, sine of 120, opposite for the y. So I cross multiply and divide. I get y is equal to 204.9 pounds. And that is the resultant force. All right, and the other one, the same thing, 100 over sine of 25 is equal to x over sine of 35. So cross multiply, x equals 135.7 pounds. And that's your second force. Okay, so really not difficult. It's a matter of making a good sketch, and the math is actually pretty easy behind it. All right, so now this next problem is, I think, a little more challenging. So let's go to it. It says Dan is flying a plane at a speed of 600 miles an hour on a bearing of 165 degrees. Oh, bearing problems. Whoop, 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 whoop. Okay, so what do you have to do when you see bearing? You have to make sure you draw your vertical line. Okay, so let's do that. Here we go. Dan's flying 165 degrees, so it's kind of down this way. So 165. And then it said there is a strong 30-mile-an-hour wind that hits the plane. It is coming from a direction of 250 degrees. So again, it's another bearing. It's coming from direction 250, even though I didn't say word bearing. So we're going to draw another dotted line, because what it's doing is it's coming. I can draw that line here. This is 250 degrees. Now, kids always have a difficult time with, if it's coming from a direction 255, which way does the arrow point? And kids have is it pointing to the left or is it pointing to the right? Just always think to yourselves, if I said the wind is coming from the north, which way is it going? Well, if it's coming from the north, isn't it going south? So what you do is if I say it's coming from 250 degrees, I go to 250 and I go the other way, because it's coming from that direction. Okay, you got to remember that. So always use the word north in its place and say I'm coming from the north. Oh, that means I'm going the other way. If I said the wind is blowing in the north direction, then you're actually going north. So if I said the wind is actually blowing in a direction of 250 degrees, then you actually blow the wind at a 250 degree angle. Okay, but if it's coming from 250, 250 is over here. So I'm blowing that way, to the right. Okay, really, really important you understand that. Well, if you guys look at these vectors, it's kind of messy here because, first of all, it's tip to tip. You can't have that. But as we talked about vectors, you can move that vector anywhere you want. So I'm just going to move it tip to tail and move it here. Okay, and then the resultant is, I'll do this in red. Here is my resultant. So think logically. The plane is 165 degrees. The wind's blowing off course. It's pushing it more towards the red, right? Okay. So we need to come up with, let me actually label these because I didn't do that. This is 600 miles an hour right here. so 600, and that wind is 30 miles an hour. So pretty much every case with a wind problem blowing against a plane, you're always going to be looking for the resultant course, which is your angle. We'll actually do the ground speed first. That means how, basically I'm looking for the magnitude of the red vector here. Okay, and you are pretty much always going to be looking for the angle between the two sides. That you're given enough information. You're going to use both of those angles. Okay, so I'm going to write that on top here. Use both angles for calculation. Really important. Okay, so I've done this so many different ways. You can do these things with alternate interior angles and the same side. I mean, there's so many ways to do these problems. But this is actually I'm re-recording this in early 2015. Okay, and I kind of figured out a little bit better way to do this problem this year for my class, for my 2014-15 school year. And what I thought of is, you know what? What if I extend this just to basically, I'm not changing the problem at all, but I'm extending it. And what I want to do then is, let me draw a couple of angles here. Well, do you guys agree if this is 165 degrees right here, then this is also 165 degrees? You guys agree with that? Because this line that I just drew here, I'll make the whole thing blue. Right? That's my transversal between the two parallel lines. So if that's 165, that other red angle is also 165 because they are same side, or they're corresponding angles. Sorry, they're corresponding angles, right? Okay, that's like a pretty key thing. So if you get that red angle is 165 degrees, and that black angle, so maybe I'll make it green, just to point out. So this green angle right here, right, that's from the wind, that's 250 degrees. Do you guys see that? I guess I'll make this in gray. I don't know if you'll be able to see this. But this angle right here is the difference between the 250 and the 165. Because once I have that green or that gray angle, that angle is the same as this angle right here. Except that gives you the angle inside the triangle because those are vertical angles. That's actually really, really handy. That's why I kind of redid this video this year, because I just think that's such an easy way to do it. Basically, I extended that one vector of the plane, not changing the problem at all, but just so you can get some, using your parallel lines, get some corresponding angle action here. And then I just subtracted the two. So that gray angle, so I'm going to put a little gray dot here, is basically 250 minus 165. Okay? And that gives me 85 degrees. And so that means that's the angle inside. So now, let me redraw this picture here. This, and this. Okay, so this is our 600. This is our 30 mile an hour wind. And then this angle here is 85 degrees. And I'm looking for x. And actually, that's the speed, that's the vector. So let's do that first. Just using the law of cosine. So it's going to be x squared is equal to 600 squared plus 30 squared minus 2 times 600 times 30 times cosine of 85 degrees. Okay? And you solve that and you get x is equal to 598.1 miles per hour. So it actually has a little bit of a headwind. A headwind means it's slowing it down. A tailwind, so it's blowing against the head of the plane, the front of the plane. And a tailwind speeds things up. You guys are here, right? Somebody says, oh, the plane went a little bit faster. It's got a nice tailwind. It's because it's pushing it from behind. But this one's actually slowing it down by 1.9 miles an hour. Okay, so it's actually blowing a little bit against the plane. All right, so anyway, that's the ground speed. And I'm asking you for the resulting course. Well, do you guys see that the plane's flying at 165 degrees and the wind is pushing it to the right and it goes to the red angle? Do you agree that, I'll do this in green, that this angle now, the angle of the resultant is less? In fact, if I subtract this angle right here, That's what I'm looking for, this angle right here. If I subtract that angle from 165, I'll get the resulting course. And again, you have to think logically, because if it blew the other way, you would be adding that angle. So thinking logically really helps you with the problem. Okay, because if it's blowing it to the left, that means the angle is increasing. If it's blowing it to the right, that means the angle is decreasing. So basically what I'm going to do is, now that I have that 598, this is 598.1 miles per hour. By the way, we're going to store this in x because we already used x here, but because we're going to use that value, and I don't want to use a rounded value. So if I use my law of sines, I get 598.1 over sine of 85. Again, this is our stored value x, and that equals 30 over sine of, we'll call this theta. So I cross multiply and take the inverse sine, which you guys already know how to do. Theta comes out to be 2.9 degrees. So remember, it's your course. So let me move this down just a little bit. Resulting course is equal to the 165, and we're subtracting 2.9 degrees. And so that gives you 162.1 degrees. There you go. Okay, so these take a lot of practice. You got to do your homework. You got to practice these problems, because if you just look at it and go, "Oh yeah, I get it," it just doesn't work. Okay, so you got to practice this in order to know what you're doing. Okay, so that's that one. And last problem here. Okay, number 5. Then, starting at Conant Yacht Club, Shivani sails 15 kilometers on a bearing of 120 degrees. Okay, so let's read the whole problem here. And then realize she must go to Math Island to pick up some trig books. She changes course and sails 40 kilometers on a bearing of 325 degrees. Find the distance from Math Island to the Conant Yacht Club. So let's kind of get started here. First of all, she's leaving the Conant Yacht Club, and she's traveling on a bearing of 120 degrees. So like this. So it's 120 degrees. And this is Conant Yacht Club, and 15 kilometers. Okay? And then she changes course and travels at a bearing of 325 degrees. So remember, this is kind of a little tricky, but 325 degrees, think of as you go to the right, it's 90 degrees. Straight down is 180. To the left is 270. And 325 is going at 360 straight up back again, right? So here it is. We'll go like this. It's a little extreme, but it's okay. So that is 325 degrees. Okay, and by the way, where she changed course, she's now at, this is Math Island up here. So I'm going to draw this vector because that's what we're trying to find. Right there, and this is Math Island. Okay, and by the way, she traveled 40 kilometers here. So there's, you got to be using your parallel lines here, and you're going to use both of the angles. Now, if you notice again, you're given a 15 and you're given a 40, right? So that angle that's in between the 15 and 40, that's the angle I'm going to need to allow me to use law of cosines. So let's kind of think a little logically. I have to use both of the angles. Okay? Well, and again, there are a lot of ways to do this. I've had kids say all kinds of different ways to do it. I'm just going to show you one way because it's just one of the ways. So let's kind of check this out here. If I say this is 120 degrees, do you guys agree that this angle right here, and this is again just one way to do it, that angle right there all the way to the bearing line, it's supplementary because, right, those are same side interior. So this blue line here is going to be 180 minus 120, which is 60 degrees. So if that angle is 60, and that whole angle here, this is 325 right here. So this small little angle right here, right there, is going to be 360 minus 325, which is going to be 35 degrees. So now I have that big blue. If I subtract the green, I actually get the angle inside here. I get this angle right here inside the triangle, which is perfect. Okay, so I got it all written out here. So 60 minus 35 gives me 25 degrees. And that's the angle between the 15 and the 40. Okay, so if we can sketch this real quickly again. So this is 25 degrees, this is 15, and this is 40, and I'm looking for the actual distance from Math Island to Coney Island Club. So these two values right here, so I'm looking for x. Okay, and then it's law of cosines. So it's x squared equals 15 squared plus 40 squared minus 2 times 15 times 40 cosine of 25 degrees. So multiply it all out and take the square root, and you get x equals 27.2 kilometers. Okay, so this one's a little different than the last one. Again, the last problem, I could have actually done something with alternate interior angles and did some subtraction. I just find that by extending that one vector really makes it a lot easier as opposed to kind of going through alternate interior. Again, there's so many ways to do these problems. As long as you show me your work and you draw a good picture, you're going to get full credit for it. If you kind of do the cheesy method and guess and just say, oh, I'm just going to subtract randomly without actually drawing a good picture, you're not going to need credit for it because it's really easy to try and guess. And gee, if you get it right, that's nice. But when you're building that bridge and you're guessing and the building and the bridge fails, I guess you didn't get it right there. Okay, and that could be lives, and it's bad. Okay, so there's no guessing. It's drawing a good sketch, and if you do that, you're usually pretty successful because, like I said, the math behind it is really pretty easy. All right, so that is your note sheet for this day and 5 problems. The homework is exactly like this. Please do not come back with your homework and say, I didn't understand how to do this one problem, because they are exactly the same. The numbers are a little bit different, exactly the same kind of problems. So if you need to, look at your notes, look at the video, but it should all be the same. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.